Now we're going to study the four innermost planets of the solar system. So we have the sun way undersized, but we'll call this the sun. And the planet closest to it is Mercury. The next planet is Venus. Then the Earth, third rock from the sun, followed by Mars, the asteroid belt, and Jupiter, which would be way back there about 19 feet. So pretend that that coffee maker is Jupiter. It's about the right distance and about the right size compared to a coffee cup, for what that's worth. But let's start with the Earth. The Earth is the biggest of the four innermost planets, but like 10 times smaller than Jupiter. And the Earth has a lot of water on its surface. By the way, the Earth is circular, but we'll use this nice coffee cup with the Baby Ruth candy bar on it as a symbol of the Earth. And so the Earth is covered with water. 70% of it is covered with water. And it has a nice thick atmosphere, not as thick as the atmosphere of Venus, but way thicker than the atmosphere of Mars or Mercury. And that atmosphere contains 79% nitrogen, 20% oxygen, and 1% soot and dust and little carbon monoxide and other things. But the important thing is that it's got 20% oxygen, which enables us to breathe. And also the Earth has is hot in the center, and it's actually liquid. And that heat spirals out to the surface. And in so doing, it creates a magnetic shield around the Earth. And that magnetic shield protects us from charged particles coming from the sun or from the stars all around. The nearest one of which is only 4 light years away. And that shield, without that shield, we would all die. And that kind of shield is pretty much missing. It's entirely absent from Venus and almost entirely missing from Mercury and from Mars. The other thing about the Earth is it has a very nice climate for everybody except old people. Old people are cold on the Earth, but everybody else is quite comfortable, except maybe at the poles. And whereas on Mercury, it's very hot on the side that faces the sun and very cold, colder than anywhere on Earth, on the side away from the sun. Now, Venus is also hot on the side that faces the sun. We'll put Mercury into its orbit here. And but it's hot all the way around because it has a very thick atmosphere, 50 times thicker than that on Earth. And that atmosphere carries the heat from the sunny side over to the cool side. Now, the rotation of the planets is very slow for Mercury and for Venus. Venus actually rotates slower than it orbits. In other words, the time that it's turning around is longer than the time it takes to go all the way around the sun. The Earth and Mars rotate each in, I think it's 24 hours for the Earth, and 28 hours for Mars. Another thing that's different about Mars and Earth versus Mercury and Venus is that we have one moon, and Mars has two moons. We call ours Moon, and because we got there first. And we call these Deimos and Phobos. All four planets travel on what amounts to a flat surface around the sun. And that's true of the next four planets, including, we'll use the pencil as the sun. So they go around like this, not in a perfectly circular way. Their orbits are somewhat elliptical, which means sometimes they're closer to the sun than they are at other times. But they're much more circular than the orbits of comets, which come whirling out of the further reaches of space and then whip right around the sun and go way out again. The asteroid belt also travels on this disk, as if it were on a flat disk. And so do Jupiter, Saturn, Uranus, and Neptune, the next four planets out. So, and in fact, the Earth has two small asteroids that travel with it, but they don't circle the Earth like our moon does. They are just fellow travelers in this orbit around the sun. Now let's focus in on Mars. And Mars, as I said, was smaller than the Earth, not by a lot, but it is smaller, and it's not as dense. And so the combination of those two leaves you with a gravity that is about 60% of Earth's. It's greater than our moon's gravity, but it is still smaller than that on Earth. So in The Martian, the characters should have bounced along. They shouldn't have been able to run normally. They should have been able to kind of do a skipping. Of course, they need to keep their helmets on, and they really couldn't spend hardly any time at all, because Mars's magnetosphere, that magnetic guard against charged particles that come from the sun and from all the billions and billions of other stars around, that magnetosphere is virtually non-existent on Mars. And so the life on Mars is not very probable, regardless of whether it has water or not, because of the lack of a magnetosphere. And that's all due to the lack of a liquid portion of the Earth that is missing from Mars and from Venus. They may have been volcanic, meaning they had circulating liquid parts, iron parts. And Mercury, for some reason, has a small magnetosphere, although there's serious doubt that it is currently volcanic. But the Earth is definitely volcanic. You can see that in the news every couple of years. And that provides life as we know it, with protection that is non-existent once you get approximately out to the moon. In other words, we can walk around on the moon. It's going to be hot on one side and cold on the other. but we can suit ourselves up easily enough, as the astronauts did, to avoid that problem. Either the astronauts were on the sunny side, but they were able to shield themselves from the heat, and the surface of the moon was not very reflective. But that shielding problem from the charged particles of the sun and all the other stars is very serious on Mars, and probably not something that can be overcome. In fact, NASA doesn't worry anymore about sending sanitized explorers to satellites, to or robots, if you will, to Mars, because there's no chance that bacteria or viruses, but primarily bacteria, could survive up there. They'd be gone after exposed to the solar wind. So that's about all we have to say. Hope you found this interesting. Bye-bye now.